We're not going to do too many Lewis dot diagrams for ionic examples because they get quite complicated. We are going to do just a few here, and then we'll move on to just writing them with a grid or looking at them. Once again, this gets very complicated and messy. So before I do any of the transfer, I'm going to go through and write out the symbols and do everything and go back and explain all of them again. So potassium is our metal. It has 1 dot. Fluorine is our nonmetal, left side of the periodic table. He has 7 dots. I'm not connecting dots, I'm not doing anything. I'm just drawing some of the dots right now. Magnesium, left side of the periodic table. He has column 2 for 2 dots. And then we have iodine, right side of the periodic table. Notice the pattern. The elements written on the left are on the left side of the periodic table, and the elements written on the right are on the right side of the periodic table. Iodine also has 7 dots. And just from before, we should notice that that would bond if it were covalent, and we have an extra dot. So we need another iodine here. And by the way, it's not covalent. You got to finish the puzzle pieces. So we're going to let that guy go. Beryllium, left side of the periodic table, has 2 dots. Sulfur is on the right side of the periodic table. He has 6 dots. And I'm going to let that guy alone. Sodium, left side of the periodic table, 1 dot. Oxygen, right side of the periodic table, 6 dots. Once again, those guys work together. We have a lonely dot here. So I have to finish the puzzle using a sodium. And to show you how ugly it can get, this takes up a lot of space. We have aluminum. And I'm going to go towards the center here. I'm using that second block in if you see through your paper. He has 3 dots. I'm going to work down low. Bromine is on the right side of the periodic table with 7 dots. Still have aluminum still has electrons needing buddies. And we still have buddies needed over here. Alright, so I basically just drew all of my dots needed for my Lewis structures and made sure every dot would eventually have a buddy. So when we do this, we need to show electron transfer and we're going to use arrows for that, and we must have charges. So potassium is going to give up and give to fluorine. It's easier to lose 1 electron than for him to find 7, and it's easier for him to find 1 than to give up 7. And keep in mind, we said the left side of the periodic table gets a positive charge. The right side of the periodic table gets a negative charge. And from last unit, we did say about the columns will tell us what our charges are also. Magnesium has 2 electrons. It's going to give 1 to this iodine and 1 to the other iodine, giving it a +2. Each iodine will get a -1 charge. Beryllium will give up to sulfur. So sulfur can take 2, beryllium can give 2, a +2 and a -2. Sodium can give to 1 oxygen, This sodium can give the other. So sodium loses 1, plus 1, and plus 1 charges, because keep in mind it has more protons than electrons. And oxygen has gained 2 electrons, and electrons are negative. Aluminum is going to give up to each of those bromines. So that would give aluminum a positive 3 charge, and each bromine a minus 1 charge. A simplified way to do this is to write a formula. So number 7, we would just have Kf. So we write what we have and how many. Number 8, we have 1 magnesium and 2 iodine. Number 9, we have Be and S. Number 10, we have Na, 2 and 1 oxygen. And number 11, we have Al, Br, 3. So just an example on how we get these formulas. If we were to do dot structures for everything, that's what we would have to do, and it can get very, very messy. And we write down how many of those items there are. So there are some other ways to cheat on these, and we'll do that with the crisscross method.